Solving equations by multiplying and dividing. Again, this should be reviewed just like the addition and subtraction. So I'm going to go through just a few examples, refresh your memory, and then you should be good to go. This one, if you're looking at the set of notes, and if you printed those out, the very first example, this is to solve s divided by 12 equals 3/4, then check our solution. Kind of two ways that you can do this. Obviously, I'm going to show you the easier way, especially since we're dealing with fractions. When you have two fractions that are equal to one another, the easiest way to solve these is to cross multiply. So if they cross multiply, we're going to multiply across. Multiply s times 4, which is 4s, and then multiply 12 times 3, which gives you 36. And then after that, then we solve using the inverse operation. So because 4 is being multiplied by s, to undo multiplication, we're going to divide. So again, we're going to keep our variable isolated, keep it where it is, don't move it. So we're going to move everything else over. So we have to get rid of that 4. So in order to get rid of the 4, as already stated, because it's multiplying, we're going to divide. And then 36 divided by 4 is 9. We're going to plug back into check. Because these are two fractions, we can look at this as simplifying our first fraction. You simplify 9 over 12, it does give you 3 over 4. Another way to look at this is to cross multiply to check to see if they're equal. So to do that, you do 9 times 4, which is 36, and then 12 times 3, which is also 36, and they do check out. The next example says negative 3 3/8 k equals 1 4/5. You can work that one out the same way. In algebra, we always change our mixed numbers to improper fractions. So you would change that, convert it, and change it to an improper fraction. That one I'll show you that one instead. Okay, so you need to change your mixed numbers that we have here into improper fractions, where the bigger number's on top. So to do that, you multiply a times negative 3, which is negative 24, plus 3, which is 24 plus 3 is 27. So it's negative 27 over 8. And then in this case, it's going to be 9 over 5. Okay, we do have a variable that's kind of sitting right there next to it. Whenever you have a variable next to the fraction, the variable always goes on top. So it can either sit beside the fraction or it can go in the numerator of the fraction. So I'm actually going to rewrite this so that my variable is in the numerator, and then we're going to cross multiply to solve just like we did in the first example that I showed you. It means the same exact thing. I haven't changed the problem at all. It's just rewriting it to something easier that we can work with. So I'm going to take what we have and I'm going to cross multiply. Negative 27 times 5 is negative 135k. Because we do have that variable there, it is getting multiplied by the 5 as well, so we keep it in there in our simplification. And then we've got 9 times 8, and then 9 times 8 is 72. So now we're back to a simpler problem that we can work with. So negative 135 is being multiplied by k. So to undo multiplication, we're going to divide. So we're going to divide both sides by negative 135. I get 1k is equal to 72 over 135 negative. I'm going to check that to make sure it cannot be simplified. It can. Our fractions are becoming negative 8 over 15. Hopefully when we check this, it's going to work. So I'm going to do the checking part on the side, and I'll do it in black ink. So I'm going to rewrite my original problem. Okay, obviously it's easier to do on a calculator, but I do see where I can cross some stuff out. I see my negative times a negative is going to give me a positive. So far I'm okay. We can cross simplify. I've got an 8 here and an 8 here. Those two can be crossed out. So I'm going to go ahead and cross those out. So now I'm left with negative 27 over 15. If I simplify negative 27 over 15 by 3, it will give me 9 over 5. And that was just doing it by hand without the calculator, but the calculator can work just as well. The other examples that are given in your notes are just like the ones that I just gave you. They're actually much easier, so you should be able to figure those out on your own through the notes. Again, just like always, if you have any questions, feel free to let me know.